Let's learn about rational exponents. So the expression a to the 1 over n can be defined as if n is an integer greater than 1 and a is a real number, then a to the 1 over n is equal to the nth root of a. Notice that the denominator becomes the index. If a is less than 0, which means if a is negative and n is an even positive integer, then a to the 1 over n is not a real number. Let's get started with some examples. Write each expression in radical notation, then evaluate the expression and round to the nearest hundredth, 2 decimal places, when appropriate. 36 to the 1/2 is the square root of 36, and the square root of 36 is 6. Number 2, this is the same as the 5th root of 32, and the 5th root of 32 is 2. 2 times 2 times 2 times 2 times 2 is 32. Number 3, this is the same as the cubed root of 20. We'll need to use our calculators, and the cubed root of 20 to 2 decimal points is 2.71. Let's take this one step further. And what if the numerator of the exponent is not 1? We can rewrite a rational exponent in radical form with these two. Notice that the denominator, n, is your index. The numerator, m, is your exponent. So let's look at example 1. This is asking us to find the square root of 16 cubed. The square root of 16 is 4, and 4 cubed is 64. We could write this as the square root of 16 cubed, but we'd have to take 16 times 16 times 16 and then take the square root of that. And clearly the first way I have written it makes it easy to use mental math. Number 2, we are looking for the cubed root of negative 27 squared. The cubed root of negative 27 is negative 3, and negative 3 squared is 9. Number 3, we're looking for the 5th root of 12 cubed, or we can find the 5th root of 12 cubed. Either way, we're going to need to use a calculator. Moving right along. From properties of exponents, we know that a to the negative n is equal to 1 over a to the n, where n is a positive integer. We now define this property for negative rational exponents. So the same rules are going to apply. If we have a negative exponent in the numerator, we can rewrite it in the denominator, and the exponent is positive. So our examples, we want to write each expression in radical notation and then evaluate if possible. So 64 to the negative 1/3 is the same thing as 1 over 64 to the 1/3, which is the same thing as 1 over the cubed root of 64 and the cubed root of 64 is 4. So this simplifies into 1/4. Number 2, we will rewrite this with a positive exponent, and then we will evaluate this. 1 over the 4th root of 81 cubed. The 4th root of 81 is 3. So we're going to evaluate 1 over 3 cubed, which is 1 over 27. Number 3, we will write this as a positive exponent. And if we need to write it in radical notation, this is 1 over the 5th root of y cubed. You can write this either way. You only need one way, but both of those are the same. Use rational exponents to write each radical expression. So now we're going to write each of these with fractional exponents. If you have to, you can write a little 2 in there. So we would write this one as x to the 3 over 2. Number 2, if you have to, you can put a 1 as an exponent on m. So this will be m to the 1/4. And number 3, we would write this as 1 over x to the 7/5. And if we wanted to write it as a negative exponent, but we always write our exponents as positives, but this is just showing you how we can go both ways. All right, you can read the next part. And what we have here for the properties of exponents, these are the exact same ones that we would have used for integer values. They will still hold for rational exponents, which just means we have fractions. So the same rules apply. So example number 1, write each expression using rational exponents and simplify. Write the answers with a positive exponent. Assume all variables are positives. Well, that's fabulous because that means we do not need absolute values. So if we rewrite this, this would be x to the 14th, y to the 21st, all of this to the 1/7 power, and a power to a power we multiply. So we're going to take 14 times 1/7 and 21 times 1/7. Number 2, the square root of 9 is 3. I got a little ahead of myself there. I want to write it as a rational exponent. Now the square root of 9 is 3. Power to a power you multiply. 4 times 1/2 is 2. Just remember, 9 to the 1/2 is equal to the square root of 9. The square root of 9 is 3. When you have an exponent, power to a power, you multiply. Number 3. We are looking to take the 3rd root or the 1/3 power. 64 to the 1/3 is the cubed root of 64, which is 4. And then a power to a power, you multiply. And that's x to the 2/3. Number 4. The 5th root of 32 is 2. And then power to a power, be a to the 1st, b to the 4/5. Number 5. We want 16 to the 1/4, which is the 4th root of 16, which is 2. Then power to power, we multiply, z to the 3/4. Number 6, we have a power to a power, so multiply. 7 over 1 times 9 over 7 is just equal to 9. So this simplifies to n to the 9th. All right, number 7. I'm gonna check your understanding here. So the square root of x is the same thing as x to the 1/2 times the cubed root of x is x to the 1/3. Same base, multiplying, keep the base, add the exponents. So we're going to add 1/2 plus 1/3, which is going to equal x to the 5/6. So we are going to rewrite from radical notation. The square root of x is the same thing as x to the 1/2. Cube root of x, x to the 1/3. Your base is x. You're multiplying, so you add the exponents. Number 8. We want the cubed root of 125. That's 5. 5 times 5 times 5 is 25. The cubed root of x to the 12th would be x to the 4th. You might have figured out you could just take 12 divided by 3 over the cubed root of y to the 30th is 10. So if I rewrite it the way I did above, (12 times 1/3 is 4. That's where I get x to the 4th. And 30 times 1/3 is 10. That's where I got y to the 10th. But it is not necessary if you can simplify it from the radical. Number 9. Number 9, we need to start inside and rewrite that with a rational exponent. So that's b to the 1/4. And then I can see that is to the square root. So I can rewrite the square root to the 1/2. I have a power to a power, so we can multiply. This simplifies into b to the 1/8. Number 10, we have a negative exponent. And so I'm going to select to flip the fraction, which will make the outside exponent positive. Now I have a power to a power. I can multiply and simplify. I'm going to use the same technique for number 11. Power to a power, we multiply and simplify. All right, on number 12, note that there's more than one way that you can show your work. I'm going to start by simplifying negative 30 divided by 6, which is negative 5. Then I'm going to simplify x cubed divided by x to the negative 1/3. When you're dividing powers, you subtract. So 3 minus 1/3, 3 minus negative 1/3. So minus minus makes a plus, will give us 10/3. And then I'm going to simplify y to the negative 1/2 over y. So negative 1/2 minus 1 is negative 3 over 2. So if I write that in the denominator, it will be a positive. Number 13, I notice I can simplify inside the parentheses first. So that's what I'm going to do. So I have a squared. I have a squared divided by a to the negative 2. So that simplifies to a to the 4th. 2 minus negative 2. And then I have b to the 9th divided by b to the 5th. Same base, dividing, keep the base, subtract the exponents. 9 minus 5 is 4. And then all of this is to the 1/4 power. So the 4th root of 16 is equal to 2. 2 to the 4th is 16. A to the 4th to the 1/4 power, power to a power you multiply. 4 times the 4th is 1. And b to the 4th to the 1/4 power, 4 times 1/4 is 1. So 2ab is my final answer. 14 is very similar to 13. We have negative 3 cubed, and then power to a power you multiply. And negative 3 cubed would be negative 27. And there's our final answer. Number 15, if you want, you can rewrite this as 1/6 times 1/5 times x to the negative 3 times x cubed times y squared times y to the negative 7th. Because we can multiply in any order, we can rewrite it like that. And then 1/6 times 1/5 is 1/30. Negative 3 plus 3 is 0. X to the 0 is 1. So I'm not going to write times 1. And then 2 minus 7 is negative 5. So if I write that in the denominator, the exponent is positive. And finally, number 16. I'm going to simplify inside first. So 15 over 18 simplifies to 5/6. X divided by x to the 4th. Same base, dividing, keep the base, subtract the exponents. 1 minus negative 4 is a positive 5. And 2 minus 3 is negative 1. So we'll put that in the denominator. So we've simplified inside of the parentheses first. All of this is to the negative 3rd. If I take the reciprocal or flip the fraction, then the power on the outside becomes positive. And then we have a power to a power. So I have 6 cubed y cubed divided by 5 cubed. And then a power to a power, we multiply. And then we'll just simplify. 6 cubed is 216. Y cubed over 125 x to the 15th. There you have it. See you next time. Bye.